Okay, here we go. Another example. So let's do the same thing with this one. I made sure that everything was correct. So we're going to put this as an augmented matrix. So we're going to write this, first of all, as the following. So it's going to be 1, 3, 5. And then negative 1, 0, negative 2. And then we have 1, 1, 3. And then of course our equals. So we have our bar. And then we have 1, 3, 5. Okay, now let's work on this now. Okay, so the first thing I'm going to do is I'm going to do negative 3 times row 1 plus row 2, negative 5 times row 1 plus row 3. And so what that's going to do, that's going to give me what? So first of all, I'm going to go 1, negative 1, 1, 1. Okay. And then this is going to be 0. Well, since we're doing negative 3, so that's going to be 3. So this is going to be 3. And then this is going to be negative 3 plus 1, which is negative 2. And then negative 3 plus 3, which is 0. And then, of course, we're going to do negative 5 times row 1 plus row 3. So that's going to be 0. And then 5 minus 2 is 3. And then we get negative 5 plus 3 is negative 2. And then we get negative 5 plus 5 is 0. Now notice right away, we've got a redundancy. Right? So immediately what we're going to get is 1, negative 1, 1, 1, 0, 3, negative 2, 0. Okay? Because all we're going to do is what? We're going to do negative, oh, not negative 3. We're going to do negative row 2 plus row 3. Right? Because all we're going to do is we're going to get zeros across the bottom. Okay, now. So this gives us a one parameter solution set. So let's write it. Okay? So again, we'll write it as a set. So it's going to be what? It's going to be, so in this case here, Z is free. Okay? So how do we solve this? This is going to give us what? Y is going to equal 2/3 Z. And that means X is going to equal Y minus Z plus 1. But then again, because we're going to do a substitution, that means that X is equal to what? 2/3 Z minus Z plus 1. And of course, what we're going to end up with is X is equal to, so it's going to be minus 1/3 Z plus 1, right? So now what does this mean when we write this out this way? So we've got x and we got y. And so if we write this in matrix, right? Well, or excuse me, in vector form, we've got one, zero, zero plus negative 1/3, 2/3. Oops. That should be a 1. Because we've got z. And then such that z is a real number. And so if you don't see it, just look at this here. If I go x, remember x is 1 plus negative 1/3 z. Right here. Negative 1/3 z plus 1. Right? So that gives me that. And if I go here, this is z is equal to what? Well, 0 plus 2/3 z, which gives me just 2/3 z. And then, of course, z is equal to 0 plus z, which is z. So, again, makes sense because it's a free variable. Okay? So, just to kind of give yourself a check, if you don't see how we go from this to this, just go the other way and check it. Okay? And that's it. Oh, and by the way, if z is 0, we get the particular solution 1, 0, 0. Okay? Talk to you later.